Hi guys, today we're going to try to animate tree. I'm going to use tyFlow for this, and this approach is uh, kinda universal. I tried with several type of trees, palm tree, evergreen, and it did work. There were some kinds that didn't, but I I think it's a working version, so we can try. So let me split the screen and create a tyFlow object. I'm going to put my editor on the right side of the screen, and we will see the tree on the left. All right. First, what I'm going to do is to detach the crown from the trunk, and but not only the leaves, but together with the branches, smaller branches. So let's do that. Um, we can try with simple selection like this, and let's see if this trunk has an ID. Yes, it's ID 1, but what else? Okay, we're lucky that those branches also 1, but these are different ID. That's 2. Okay, then we can easily select um, from here, but just just to show another way, because not every tree has proper ID assigned. I'll show you another way. So we are going to use select modifier. So I'm going to select by elements, and in the selection mode, I'm going to pick material ID, and material ID here I can type what ID I want to select. Let's say I want to select 2, 3, sorry, with comma, 2 and 3, etc. And it will be added. But in my case, I need just first ID, and I already can detach from the main model this selection. So when it's selected, I can just add the edit poly and detach. Okay. Yeah, and let me just move everything to my tyFlow layer. And maybe I can delete unnecessary layers. Yep, so this detached object is a trunk. This is main model. And I need to invert the selection and get my top part of the tree. So I'm going to delete this edit poly, and here in the tySelect, invert selection, adding edit poly again, and detaching the top part. Okay. For now, I can hide my main model of the tree, and this detached part will be a crown. Yep. So what are we going to do now is to work with tyFlow. I'm going to scatter a bunch of points on my crown, on my top part. I can hide the trunk, I don't need it yet. So of course I'm going to scatter points in the frame 0. I don't need them to be born by the timeline. And the amount, let's put 1,000 for now. Let's make these points more prominent color. And where to scatter, we're specifying position object. I'm picking my crown geometry, and the points are scattered. I like to make them bigger, large dots. All right. Next, what we are going to do is to select some of the points that are closer to the trunk, so they will not move during the animation. And we are going to do that by surface test. And in the surface test object, I'm going to pick my trunk. So the points are close to the trunk will be pinned to it. In the surface test output, I'm going to create a new event. As you can see, yeah, let me change the color. These red points are close to the trunk and they are going to be pinned. Mm, In the surface test, we can adjust the distance, how far this pinned particles will be affected. Now it's zero 0.1 meter, but I can increase it if I want. Let's make it something like that, 0.3 maybe. And to pin them, we are going to use object bind operator. Let's pick the object we want to bind to, and this is a trunk. Selected. Okay, so these yellow points we need them to be connected. And for that, we will use particle bind. Yeah, I think I can hide my geometry for now for the clear view. And in the particle bind, what it does, it connects several points between each other, and that bind can be um, rigid or it could be more soft, so it can stretch. This is exactly what we are looking for now. Let me, yeah, so here, first let's enable the show binding so we visually can see how they work, these connections. So show bindings, and in the proximity bind, we will specify the multiplier, the distance, how far each particle should be from another one to be connected. So if you zoom in closer, maybe we already have, yeah, there's the connection. So this distance is equal or less than 1.5, 0.1 meter. Yeah. And by increasing this value, we will get more and more connections. So I'm going to increase the value. Let's say 10. Actually, we can increase more, maybe 50. And max binds parameter needs for the max binds parameter needs for defining how many points and the max binds parameter defines how many times one point can be bind to another points, and we can decrease this value from 100 to maybe 20. Let's start from that. So having our binds created, we can introduce some gravity and see how it works. So I'm going to create a force here, and nothing, we will add nothing to forces, but we will initiate the strength of the gravity. Real world gravity would be too much for this simulation, so I usually created much less, something like this. And maybe we also should to increase the steps per frame. I'm selecting the tyFlow object and in the timestamp changing to, let's say, 1 divided by 2. So each in between frame will be calculated and the simulation will be more precise. Let's run the sim. Okay, as you can see, some parts were not connected and they just fall apart. This is okay, we're gonna fix this. But you already can see how the structure is working. It's bouncing, and it's quite rigid now. So we can first try to fix this falling part and then rigidity. For that, in the particle bind, what we can do is increase max binds from 20, let's say 30 maybe. Let's test. Still false. We can increase the distance just slightly. Still didn't catch. Okay, let's increase more. Now it's attached but partly, so that will ruin our simulation. Okay, in this case, it's already quite rigid, this tree. So in this case, I'm going to lower the multiplier to something like 30, maybe 40, 35. And I will introduce another particle bind, but this one will connect the particles that are furthest one from another. In the particle bind, the first one, if you take a look at the default state, in the sorting, sort by distance closest. And what we need to do is to have rigidity between furthest ones. So the second one, I will change the sorting to furthest. We can also enable the show bindings to see them. And I'm going to change the color. Disabling the first show bindings just to keep the second one. And we need, of course, increase the distance now in the multiplier. Let's put something like 10. Yeah, we need to find the proper value. Let's test with this option. Yeah, we need to catch those that are separated now. Okay, and the max bind, we don't need that much connections because we already have two particle bind operators. That will be too rigid. Okay, for now let's leave it as is, and in the soft stiffness, let's lower this value. So stiffness does what it's written. It adjusting the stiffness of the connections. The lower the value, the less the stiffness. And I'm going to lower this value for both. Okay, something like that. Let's keep it as is now, and let's introduce some noise, wind that will wobble our tree. But it should be, of course, very soft wind. So in the strength, the same force where we put the gravity in, we will increase the strength. Let's try 0.0, 0.1. Yeah, and in the scale, maybe it should be smaller, like 30, and also frequency. So our wind will change, so the noise will change during the time. And that frequency, yeah. So all these three parameters must be tested, and you will never guess from first try. It's always trying and trying to find the golden medium. Let's play the animation. That might work. Of course, we don't want to see this as a final output. So for testing this on our geometry, I'm going to create a copy of our crown object. Clone, copy, and rename it as crown underscore skin. Hiding original crown, and in the crown skin, it should not be instance copy, that's important. We are adding a modifier tyParticle bind. tyParticle skin. In tyParticle skin, we should specify from where that information should be grabbed. In our case, this is tyFlow object. And let's get rid of these bindings, show binding disabled. And let's play the simulation. It's already kind of working. And of course, it requires time to adjust adjust those parameters, the amount of bindings, the stiffness, to find the best result. We can unhide our trunk and hide dots just by disabling the display operator. Yeah, so now we can cache out our particle system by just creating a particle export. Yeah, of course, don't forget to enable the license. So I'm picking the tie cache and setting my frame range to the timeline, which is 100 frames. And of course the output. And here I prefer to specify the layer where I want my tie cache object to be created. And this is tyFlow 11 tyFlow layer. So let's just pick that. And we are ready to go. So generate tie cache files. That was super quick. From now on, we can disable our tyFlow totally. I'm gonna close it. But as you remember, the crown had plugged tyFlow object into tyParticle skin. I'm going to switch that to tyCache. Yeah. And yeah, we are ready to export tyPreview just to see it in real time. The tyPreview is ready. Yeah, so this way, I think it's perfect for not for the close-ups, but for middle, mid-ground, background. Yeah, because of, you see, like this thing. For the close-ups, it should be proper simulation with the bone structure. but for the non hero object, I think it's gonna work. So thank you for the attention and see you in the next one.